So we have a cylindrical tank that's 18 feet high with a radius of 12, and it's filled to a depth of 18. We want the work done pumping the water out over the edge of the tank, and we'll just use delta for the density of water. It's 62.4 pounds per foot cubed, but I'm just going to leave the final answer in terms of delta. So let's just kind of see what we have going on. So first thing we can do is draw the tank with the water. The total height of the tank is 15 feet. The radius is 12. And then the height of the water is actually the total height of the tank is 18, the height of the water is 15, excuse me. So here's the drawing that we're going to make all our markings on. And so first thing I like to do is just find out what that ith slice looks like. So I put it in here. Here's my ith slice. Let's give it a thickness of delta H, and we'll say that it's H sub I units above the bottom of the tank. So there's my ith slice. So very first thing I'm going to do is find the volume of the ith slice. Now one of the nice things about a cylinder is it has the same radius the whole way up. So the volume of the ith slice is just going to be pi times the radius squared times the height, which is delta H, or 144 pi delta H. Okay? Kind of nice. We don't have a variable in there. So this one's going to go pretty quick. Next thing we can do is we can turn that into the force just by multiplying by delta. So 144 delta pi delta H. Now we could put it in the 62.4. I'm going to actually give the final answer in terms of delta, and then to find out numerically what it is, it's just a matter of putting it in your calculator. So I'm not too concerned about that. The last thing we need is we got to figure out how far that slice is getting moved to turn this into work. Well, here's that slice. So how far does that slice have to go to get out of here? Well, remember the whole thing is 18. It's H sub I to the slice, so 18 minus H sub I is the distance that slice is moving. So we have 144 delta pi times 18 minus H sub I delta H. We are now ready for our work integral. So, actually, let me rewrite this because I'm going to pull all the constants out front just to save some space. So 144 delta pi 18 minus H dH, and now we need limits. Remember that you're integrating over the water. So the water is going to go from a H level of 0 up to 15. Not 18, because it's not a full tank. If it were, then it'd be 18. So, let's finish this up. So we have 144 delta pi times 18H minus H squared over 2 from 0 to 15. We really only need to worry about plugging in the upper limit. The bottom limit's going to make the whole thing 0. So we have 144 pi times delta. I kind of switched the order there by accident. Doesn't make too big a difference. 18 times 15 minus 15 squared over 2. And we will go ahead and calculate. I'm going to calculate all the numbers together, but like I said, I'm going to leave it in terms of delta and pi. So we have 18 times 15 minus 15 squared divided by 2. So let's take care of that part first, times the 144. So actually it's already a large number without multiplying by delta and pi. So we get 22,680 delta pi, I switched it again, foot-pounds for our total work.